Hi, everyone. My name is Ali Bhatti. I'm a PhD candidate at UC Berkeley, and today I'm really excited to talk about how we can advance assessment, utilizing item response theory and Rasch analysis to improve Likert survey research. And before I go any further, you might have heard me say Likert and thought, why is he saying Likert? Well, that's because that's how you pronounce it. It's a person's name. And I, for the longest time, used to say Likert all the time. But there's actually a journal article in the Journal of Applied Measurement with the title of Likert is pronounced Likert, not Likert. And data are ordinal, not interval. And I'll talk much more about that as we go through the following presentation. But that was mind-blowing to me. Just don't judge me for saying Likert from this point forward. All right, I'd like to get us started with a short video that I think some of you might recognize, at least where it comes from. Okay.
Discussing those questionnaires that you filled in this morning. It is wrong to make personal calls during work hours. Now, some of you marked that you very strongly agree, but ideally you would have selected totally agree.
I thought very strongly agree sounded stronger than totally agree.
Corporate would like to emphasize that ideally you would all totally agree with that statement.
Well, I think we can all totally agree that Holly is totally fantastic.
Thank you. Okay.
All right, so I think that video actually encompasses so much of what I want to talk about today. And I'd like to, for all of us actually to engage in a short activity based on the video where we're going to look at a Likert type question. So let's imagine you get this survey and the survey question says, that clip from The Office was a great way to start this talk. And you get the typical standard Likert survey responses. Strongly disagree, all the way up to strongly agree, and you have this sort of scale that you have to manage and figure out. Usually as education researchers, when we give items to students that have this scale, our job is to convert this ordinal scale, there's a category of ordered categories here, and convert that into an interval format. Usually we just go 1, 2, 3, 4, 5, and then we utilize parametric statistics like t-tests and significance tests and figuring out the mean, and utilize all of that so that we can eventually get a better understanding of how did students respond to this item. What I'm going to argue today is that our typical interpretation of this type of scale and the typical analysis that we do is problematic, and it's problematic for multiple reasons. So just to give you an emphasis of that, what's the big deal? Why should this matter? And really it comes down to the fact that there are problems with our general Likert scale analysis that we do. There are psychometric red flags, meaning that there are variable category distances within and between people. This just means that when we think about ourselves, and let's say question A is this following question, the distance that we consider strongly disagree to disagree might be different for question A versus question B. And this will definitely be the case between items and between people as well. The distance you consider between strongly disagree and disagree is not the same what I consider. And it just depends on the question, the circumstance, whatever it might be. So clearly there's a problem there, and we utilize the same response format and the same response analysis for everyone. And then ultimately, we're also doing what I would consider, not the greatest of statistics, because we're treating this ordinal data, strongly disagree, disagree, neutral agree, and strongly agree, as interval data. And that's not good statistics. So instead, what I propose is utilizing something called item response theory. We don't have the time to talk about item response theory in all of its details. Let's just call item response theory for now a psychometric approach that better accommodates the Likert scale response format. From this point forward, I'll be utilizing Rasch analysis specifically because that's what our study utilized. And just consider that a subclass of IRT models for right now. We don't need to get into the details of what the difference is and what the specificities are between Rasch and IRT. But I'm going to propose that that is the way we can move forward and do a better job of analyzing these types of survey research questions. So the context of our study comes from this course called Bioinspired Design. This is an awesome, awesome course where students from any major, any year, no prerequisites, engage in authentic science. And what I mean by that is students go into the primary literature, they find a design solution from nature to solve a design problem in society. And there are so many different ideas students come up with. Just to give you a glimpse of that, these are some of the final projects that they do. We do sort of a poster session where they take the inspiration from nature, show us what can be impacted in society. And we believe as students are engaging in this process, they are becoming innovators. Their self-perception of innovation and their ability to innovate is improving. And that's where our research comes from, and that's where our Likert survey research is going to be headed towards. And I'll show you that in the next couple of slides. So overall, we wanted to ask, what is the change? Is there a change in students' self-perception of innovation skills as a result of completing this Bioinspired Design course? We did this in two ways. I'm going to first show you a general Likert scale analysis. This is the standard that we usually see pre and post the course. Then I would like to utilize that information to inform the Rasch analysis that we eventually did to somewhat quell the difficulties that we end up having with general Likert scale analysis that I mentioned before. So this study had the main goal of comparing students' self-perception of this innovation skills construct before and after the course. We utilized the 4 building blocks of assessment framework by Mark Wilson. This is in his book, Constructing Measures, which I'll talk about. We did this through a 26 Likert item pre-post innovation skills survey that was validated. And then we analyzed this survey through Rasch analysis, like I mentioned before. So Rasch analysis, just don't forget, is that psychometric approach that better accommodates blah, 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 blah. It's, I think, the solution to the relative problem of general Likert scale analysis. So considering those 4 building blocks, we don't have the time to go over each of them and how they integrate. We're working on a manuscript right now that talks about all of them and how it worked in this study. But we're going to focus specifically, at least to get an understanding of what we're measuring on the construct map portion of these 4 building blocks proposed by Mark Wilson. This is essentially a way to measure whatever you're trying to measure in an iterative and robust framework. So the construct map really that we're focusing on here is innovation skills. And we consider innovation skills to be a multidimensional construct that spans across these 3 areas: scientific discovery and translation, interdisciplinary thinking, and interdisciplinary collaboration. We believe students need to engage in these things in order for them to be the innovators that they need to be in this course. And we also hypothesize that students increase in each of these sort of sub-constructs as they go through the course. And what I mean by that increase is better emphasized by just focusing on one of them, just so that we're on the same page. Let's focus on the first building block of the construct map, and let's look at the scientific discovery and translation construct map. The best way to understand this is to just look at the top and the bottom. Look at the extremes. Notice how on the lower level of this construct, we hypothesize that students can be on this level as well. Like they can come to the course in this way of just having a required level of understanding, let's call it, meaning that they read scientific publications because they're required. That's just part of the course. We hope that eventually, as they go through the course and read many scientific publications, they get to a leader level. And that's what we mean by the growth that we're hoping to see, where they can translate fundamental principles from scientific publications to create novel designs, a big sort of, multi-dimensional learning objective that we have. We hypothesize growth as a result of this course, and we're going to try to measure that growth and map that growth through this construct map approach that we have here. So let's look at the general Likert scale analysis results. This is just pre-post. We had a 26-item survey. How did the results sort of end up in the standard form that we usually have? Well, what we noticed was growth. That was great. We saw growth pre to post in all of the items that are related to scientific discovery and translation. We saw growth in all of the items related to interdisciplinary thinking, and we saw growth in interdisciplinary collaboration as well. So all 3 of those subconstructs had growth pre to post. And this is just through a mean Likert rating comparison between pre and post. So just to give you a summary of that, increases in agreeability for all items. The mean score for each survey item increased from pre to post, and then growth in each dimension of that innovation skills construct we just talked about. The thing is, this sounds great, it looks great, but we can be better. And I really believe this is not enough to just stop there. And I think most assessment in undergraduate biology education actually does stop here. And so what I propose is that we keep going with something called Rasch analysis. So let's look at our Rasch analysis results. The Rasch analysis results, I think, help quell, once again, those difficulties that I had mentioned before of the general Likert scale analysis that we end up doing. So just to give you a 101 of Rasch analysis, again, we don't have the time to go into the nitty-gritty details of this measurement model and stuff like that, but there are great resources listed on the bottom right here to help you with it. Rasch analysis is model-based measurement, meaning that we're going to build a measurement scale and check whether our data fit that model. This is a very, what I would call scientific approach to assessment. Rather than just assuming we have some sort of results of like growth, let's actually put it towards a model-based approach. And importantly, what we end up having is a statistically appropriate translation of what we recognized as ordinal survey responses, strongly disagree, disagree, neutral, etc., into interval data that can be visualized. And the really cool part about this is that the visualization is one of the building blocks that we have here, which we call a right map. It's an item person right map. If you're not familiar with it, these are the basics, at least for the context of this course. Let's imagine that the more positive response, let's say strongly agree, maps to higher levels of the construct map, kind of like we saw in the beginning when I showed you the scientific discovery and translation construct map. Let's imagine that the more positive responses actually indicate a higher person ability. They are higher on that level of the construct. And then we'll also imagine that items with lots of strongly agree, this indicates this is an easy item. This is something that most students are able to endorse pretty easily. So let's look at that in the context of the research, in the context of the study that we had here. So I'm going to break this down with 3 graphs. Please don't get intimidated. I promise they're consumable, they're digestible. We'll just break them down piece by piece. So the first thing I want to show you is the pre-right map. So this is a item person right map, meaning that on the right side over here, we have items. These items are distributed according to their difficulty, meaning that the easiest items are on the bottom of this logit scale. Don't worry about the negative or positive. Just know that that's the easiest. And then the most difficult items are at the top. And then we have an array in between. And then on the left side of the histogram here, we also are correspondingly mapping persons or students or respondents of the survey and how they fall, not in terms of difficulty, but in terms of ability. So the higher ability students are over here, the lower ability students are over here, and there's sort of an in-between. One thing we'll recognize that's pretty good is that we see a pretty normal distribution here, a nice spread, if you will. And now let's see what happens in the post. So this is before the course. This is how they sort of showed up in the course. Now, after the course, what do we notice? Now, it might not be that easy to see, but if we recognize that these zeros are aligned here, we actually see a push up of this distribution. Distribution has pushed up, and that just means growth, meaning that there are so many more students at the higher ability end over here, so much so that they don't have items that map onto them. This actually indicates we need more items to map onto these students, but nonetheless, we see significant growth between pre and post. And I think the best way to visualize this is through this overlaid map here that simplifies things, I think, pretty clearly. What we end up seeing is that we have a peak over here, then we have a peak over here, and we see this growth that ends up happening between pre and post. Now, just to put this into more quantitative terms, the Rasch analysis results help us see the following. We had a 0.97, about 1 logit gain in student ability. Just don't worry about too much the meaning behind the logit term. That's just a unit of growth. We'll call that a unit of analysis here. But to put it into more of a understandable perspective, you can convert logits into standard deviations of growth. And we had, again, nearly an entire standard deviation of growth between pre and post in a 1-semester course, a 1-semester intervention, if you will, in this innovation skills construct, which is really positive. Ultimately, we also saw a relatively large effect size within this of 0.75. This is nearly a large effect size, which is about 0.8 under Cohen's recommendations. But in the context of an educational intervention, this is actually a really significant effect size that really helps us see the impact that we have here. And to simplify it even further, this essentially means this 1 logit gain, this 1 standard deviation of growth. This essentially means everybody was able to increase 1 step in the Likert scale across all the items, from agree to strongly agree, let's say, as an example. If they were previously agree on an item, they went to strongly agree on an item. Now, this helps us see, I think, overall, a better way to analyze the Likert scale because it's psychometrically robust. It is a model-based measurement, and it also doesn't have the faults of the bad statistics that I mentioned before. But maybe we can do it even better than the Likert scale. And what I want to introduce to you in sort of a conclusion format is the fact that our next step is actually to take the items from this survey, the Likert items, and convert them to what are called Gutman scale items. So let's imagine this item here I can translate fundamental principles from scientific publications to create novel designs. We imagine as a student completes the course, they get better at this item. They go from an endorsement of agree maybe in the beginning to strongly agree, or disagree to strongly agree, even a higher jump, whatever it might be. That's what we hypothesized. That's what we saw. We think we can go even better than this Likert item and turn it into a Gutman item, meaning that we're going to map the construct itself within the item. So look at the following. And again, I think the best way to understand this is the top and the bottom of the scale. What if we change the question to, which statement best reflects your ability to engage with scientific publications? Instead of making it a very subjective, do I strongly disagree or do I strongly agree? Let's actually have students choose what they did in the course, right? What actually reflects their answers. And if we look at the levels that are mapped here, the required level says, I can read and generally understand scientific publications. Compare that to the leader level, which is I can translate fundamental principles from scientific publications to create novel designs. And I think that's again a next step that we hope to do for the entire survey, so that we can better map student growth in a way that reflects the true sort of learning that they undergo as they participate in this course and complete this course. So overall, just to conclude, simple statement here, but I think it's powerful and I think it's impactful. By doing more robust assessment, getting better assessment and measurement and overall principles related to our Likert scale analysis, we can better show what really matters, and that's student growth. Thank you so much. You can connect with me by scanning this QR code. It gives you access to my email, and I would love to hear any questions that you have related to this talk. Thank you.